Have you ever wondered how many dimensions exist according to string theory? It's a question that tickles the curiosity of both physicists and laymen alike. You see, string theory, in all its mathematical elegance, proposes a fascinating concept, that the number of space-time dimensions is not set in stone by any physical principle. Instead, it's the mathematical consistency of the theory itself that dictates the count. This means the number of dimensions could be more than what we're familiar with. Different versions of string theory predict different numbers of dimensions. The most widely studied versions, however, point towards an intriguing 10 or 11 dimensions. Yes, you heard that right. 10 or 11 dimensions, not just the 3 spatial and 1 temporal dimension that we're accustomed to. So we live in a world that may have more dimensions than we can perceive. Quite a mind bender, isn't it? But how come we only experience 4 dimensions? The answer lies in the concept of compactification. Imagine a tightrope walker balancing on a wire. From afar, that wire looks like a one-dimensional line, but up close, we see that it's really a 3-dimensional object, a cylinder. This is similar to how compactified dimensions work in string theory. Beyond the 3 spatial dimensions we're familiar with, length, width, and height, and the 1 temporal dimension at time, string theory suggests there are extra dimensions that are so minuscule, they're virtually imperceptible. These dimensions are thought to be compactified or curled up at incredibly small scales, in a way similar to how the wire appears one-dimensional from a distance. Now you might be wondering, why don't we notice these extra dimensions? Well, it's because they're curled up so tightly and are so small that we just can't perceive them directly. It's like trying to see individual grains of sand on a beach from an airplane. They're there, but from our perspective, they're just too tiny to see. But here's the fascinating part. Even though we can't directly perceive these compactified dimensions, they may still have an impact on our observable universe. The shape and size of these extra dimensions could potentially affect the properties of particles and forces that we can observe. For example, the way a particle behaves in our 4-dimensional world might be influenced by the shape of these compactified dimensions. These dimensions could potentially alter the way particles interact with each other, how they move, and even their fundamental properties. So, while these extra dimensions are hidden from our direct perception, they're not completely detached from our reality. They could be subtly shaping the world as we know it, influencing the behavior of particles and forces in our 4-dimensional universe. So the extra dimensions, while hidden from our direct perception, could still influence our observable universe. Are there any efforts to prove the existence of these extra dimensions? Well, indeed there are. Scientists are tirelessly working to uncover the secrets of the universe, and part of that endeavor involves trying to find evidence for the existence of these extra dimensions. Now you might be wondering, how is that even possible? What does it take to prove something so abstract and seemingly unfathomable? One of the most ambitious undertakings in this quest is the use of high-energy experiments, such as those performed at the Large Hadron Collider, or LHC for short. The LHC is the world's largest and highest energy particle collider, and it's here that scientists hope to find some clues pointing towards extra dimensions. So what are these elusive signs that physicists are looking for? One potential sign could be deviations from the inverse square law of gravity. This law states that the force of gravity acting between 2 objects decreases with the square of the distance that separates them. If extra dimensions do exist, they could potentially alter this law at very small scales, which would be a monumental discovery. Another exciting possibility is the production of mini black holes. According to some versions of string theory, the energy at which these tiny black holes can be produced is lowered if there are extra dimensions. If scientists at the LHC were to create a mini black hole, it would be a strong indication of extra dimensions. But as tantalizing as these possibilities are, it's important to note that so far, no concrete evidence for extra dimensions has been found. Despite the meticulous efforts of physicists around the world, these extra dimensions remain a theoretical concept for now. Yet, this doesn't mean the search is over, far from it. Scientists continue to push the boundaries, testing the limits of our current understanding and exploring new frontiers. While the search for evidence continues, the idea of extra dimensions opens up fascinating possibilities for our understanding of the universe.